Hey everybody, I'm going to make a quick video on comparing two means. This is part of 3.1. So what's going on is you're going to look at two data sets. So set A has a sample size of 5 and a sample mean of 4. And set B has a sample size of 50 and a sample mean of 4. Okay, so right off the bat, we know set A has a small sample. They've only got 5, where set B has a larger sample of 50. So part A says, suppose the number 26 is included as an additional data point or data value in set A. So now we're going to compute the new sample mean of the data set, and it gives me the formula. So again, okay, all I'm doing is I've got set A, which has 5 values and a sample mean of 4, and I'm going to add the value of 26 to it. Okay, so step 1 is I'm going to use this nasty formula, but it's really easier than this nasty formula. So I know the sample mean, excuse me, is 4 and the sample size is 5. So before I even add that number 26, I need to solve this. And it gives you right here the formula for it. So the sum of all the x's is 4 times 5. And if I do that, I get 20, okay? So that is my sum of all the x's, okay? So then right here, I've got my sum of all my x's, which, oops, sorry, I'm going to put right here. Gosh darn it, it's one of those days today. I'm going to put it in yellow here, and I'm going to put it here, okay? But remember, the problem right here wants me to add 26. So there's the new value of 26. So from there, I get 46, all right? So then what am I going to do next? So 46 goes here, and I divide by 6. Why do I divide by 6? Okay, so I'm going to put right here. Remember to add one value to the sample size. So 5 plus 1 equals 6. Remember, my sample size up here is 5, and I'm adding that value, which is 26, which is one value, gives me 6. So 46 divided by 6 gives me 7.666. All right. It wants me to do it for sample B, or for set B. Okay, remember, set B had the larger sample size. It had 50. I do basically the exact same thing. So set B, sample size is 50, sample mean is 4. All right, so remember, and I can use the formula again, I kind of think is easier. So if I use the summation of x, that's all that means, equals 4, again, which is my mean, sample mean, times 50 gives me 200. Okay, remember, that again, then I'm going to highlight it again in yellow if I can get it to work. Okay, that is my summation of x for set B. And again, I'm going to put it down here, okay? Again, what I'm doing, I'm going to add 26 to my data set like I did before. Ooh, it would help if I could count. So I'm going to add 26 again. Again, I did that. So if I do that, then I get 226. So, and then remember to add one value to the n. So 50 plus 1 equals 51. Okay. So 226 divided by 51 gives me 4.431. All right, so let's take a step back. Set A had a really small sample size. Set B had a larger sample size. By me adding this one value, this made my sample mean for set A go up a lot. It went from 4 to 7.6. But when I added it to set B, because I had a larger sample size, it didn't increase that much. It did a little bit, but not a lot. So what does that tell you? When you add values to small sample sizes, it will affect your mean. But when you add one data value to a sample that has a lot of values, it's probably not going to affect your mean unless it's like an outlier. So what this whole problem thing is trying to get at is, why does the addition of the number 26 to each data set change the mean for set A more than it does for set B? All has to do with the sample size. So set B has a larger number of data values than set A. So to find the mean of B, we divide by the sum of the values by the larger value than A. That's kind of crazy. Okay. Set B has more data values than set A. When we add an additional data value, set B has a relatively small increase in the mean of that data set than set A. Okay, so what does that mean? Set B is not affected as much as set A because set B has a larger sample size. So now when you consider how much the mean of each new data set is found, the new set A has a total of 6 data values. So to find the mean, we divide by the sum of 6. The new set B has 51 data values. So to find the mean, we divide by the sum of the sum of the values by 51. So to conclude, when you add an additional value to a smaller data set, it will affect the mean more than the addition of the same value to a larger data set. So again, that is when you're comparing the two data sets, because the rule of thumb is sample sizes that have data sets that have small sample sizes will be affected more when you start adding data values. Samples that have large sample sizes are not affected as much. That's what they're trying to get at. I don't think they did the best job, but that's what they're trying to get at, is small sample sizes are really, really affected by new values. Larger sample sizes, not really. Hope this helps.